Ever wondered how machines learn and think? Well, the answer lies in a concept called deep learning. It's a fascinating world where we endeavor to create machines that can not only compute but also learn and make decisions, much like us humans. Thank you for joining us here at Innovative Muse, where we explore the wonders of technology as it meets innovation. Welcome in. Now, deep learning is actually nestled within the broader field of machine learning, which in turn is a branch of the vast tree of artificial intelligence. In essence, the goal of deep learning is to mimic the workings of the human brain in processing data, recognizing patterns, and using this information to aid in decision-making. It's like teaching a machine to be a detective, sifting through heaps of data, picking out the relevant clues, and solving the mystery. Sounds complex? Well, don't worry, no need to be intimidated. We are going to break this down in a simple and fun way. Imagine the brain, it's filled with neurons, right? In deep learning, we have something similar called neural networks. Let's take a moment to untangle this concept. Picture a vast web of interconnected nodes, each node representing a neuron in the human brain. This is the basic structure of a neural network. These nodes, or artificial neurons, are organized into layers. There's an input layer that receives data, an output layer that makes a decision or prediction about the input, and in between, you have one or more hidden layers where the magic really happens. Now, each of these artificial neurons is a small processing unit. It takes several inputs, applies a weight to them, adds them up, and then uses an activation function to decide whether and to what extent that information should move forward through the network. Sound complicated? Let's simplify it. Imagine you're trying to recognize a cat in a photo. The input layer takes the pixels of the image. The hidden layers might recognize edges, shapes, and textures. And the output layer decides, based on all this information, whether the image contains a cat or not. But how does the network know what features to look for? This is where training comes in. We feed the network thousands or even millions of examples, and it adjusts the weights applied to the inputs in order to improve its predictions. This is a lot like how we humans learn from experience. The more examples it sees, the better it gets at recognizing patterns. So, in a nutshell, neural networks are a series of algorithms that mimic the operations of a human brain to recognize relationships between vast amounts of data. They're the powerhouse behind deep learning, allowing machines to make sense of the world in a way that's eerily similar to our own cognitive processes. So, just like our brain connects the dots, these neural networks do the same for machines. Now that we know what neural networks are, how do they learn? This question takes us into the heart of deep learning. The learning process of deep learning is a fascinating journey, and it starts with data. Imagine data as the raw material. It's like the clay in the hands of a potter, shapeless and formless. But the potter, with his skill and creativity, molds it into a beautiful pot. Similarly, deep learning algorithms take raw data, process it, and draw meaningful insights. This process is known as training. But what exactly is training? It's essentially a phase where we feed data to our model, letting it adjust its internal parameters to learn the structure of the data. It's like showing a child different shapes and asking them to differentiate between a square and a circle. Initially, the child may struggle, but with time and repetition, the child learns to distinguish between the two. In the same way, a deep learning model starts with a blank slate. As we feed it more and more data, it begins to recognize patterns and structures. This iterative process of adjusting its parameters based on the data it's exposed to is how a model learns. Interestingly, this learning isn't just about memorizing data, it's about understanding the underlying patterns and relationships within the data. This is where the concept of representation learning comes into play. Representation learning is the ability of a machine to automatically identify and utilize meaningful representations from raw data. It's like learning to recognize the essence of an object rather than just its superficial features. So, the learning process in deep learning is a combination of training and representation learning. It's a process where the machine learns to understand the world bit by bit, data point by data point. In simple terms, it's like studying for an exam. The more you study, the more you understand. And just like with studying, the quality of the data matters as much as the quantity. The right data can make all the difference in the learning outcomes of a deep learning model. Deep learning is not just a cool concept, it's actually being used in our everyday lives. Let's delve into some of its fascinating applications that are shaping the way we interact with technology. First off, we have computer vision. By teaching machines to interpret and understand the visual world, deep learning is revolutionizing industries. Think about facial recognition in your smartphone, or the automatic tagging feature in your photo gallery. All these are powered by deep learning algorithms that can identify patterns and objects just like the human eye. Next up, natural language processing. This is the technology behind your favorite voice assistant. Deep learning helps computers understand, interpret, and generate human language. It's what allows you to ask your smart speaker for the weather forecast or to play your favorite song. It's also the tech that powers chatbots, making customer service more efficient and accessible. Then there's speech recognition, an offshoot of natural language processing. This technology converts spoken language into written text. It's the magic behind transcription services, voice-controlled virtual assistants, and even some real-time translation apps. But it's not all about gadgets and gizmos. Deep learning is making waves in the financial sector too. It's helping banks detect fraudulent transactions, and investment firms forecast market trends. And let's not forget about the automotive industry. The dream of self-driving cars is inching closer to reality, thanks to deep learning. By processing vast amounts of data from various sensors, these cars can navigate the roads, recognize traffic signs, and even detect pedestrians. In the realm of entertainment, deep learning is behind your recommended shows on streaming platforms. It understands your viewing habits and suggests content you might enjoy. These are just a few examples. Deep learning is transforming industries, making technology more interactive, and opening up a world of possibilities. It's safe to say that we're only scratching the surface of what this powerful tool can do. From voice assistants to self-driving cars, deep learning is everywhere. One of the most promising applications of deep learning is in healthcare. This powerful tool is being harnessed to detect diseases at their earliest stages, when treatment is often most effective. By analyzing complex medical images, deep learning algorithms can identify subtle changes that may be indicative of conditions such as cancer or heart disease, often with greater accuracy than human doctors. Beyond detection, deep learning is also being used to accelerate drug discovery. By sifting through vast amounts of data on molecular structures and biological interactions, these algorithms can predict the effectiveness of potential medications, dramatically shortening the traditionally lengthy drug development process. Moreover, with the rise of telemedicine, deep learning algorithms are enabling remote patient monitoring and diagnosis, bringing healthcare to those who may have previously struggled to access it. Deep learning is revolutionizing healthcare, making early detection and treatment a reality. Like any technology, deep learning has its challenges and an exciting future. The path to the full realization of deep learning's potential is strewn with obstacles. One of the primary challenges is data privacy. As deep learning models require massive amounts of data for training, concerns about privacy and security are bound to arise. Another challenge is the need for extensive computational resources. Deep learning models are complex and require powerful hardware, which can be a barrier for smaller organizations or individuals. Additionally, explainability or interpretability remains a significant hurdle. It's often difficult to understand why a deep learning model made a particular decision, which can be problematic in fields such as healthcare or finance, where transparency is crucial. Yet, the future of deep learning is bright. With advancements in technology such as quantum computing and edge AI, we can expect to overcome many of these challenges. Despite the challenges, the future of deep learning looks promising. So we've demystified deep learning, but what does it all mean? Well, let's take a moment to reflect on the journey we've just been on. We've defined deep learning and understood how it's all about neural networks and the learning process, taking in raw data and transforming it through training. We've seen how deep learning applications are wide and varied, from computer vision to neural language processing and speech recognition, revolutionizing the way we interact with technology. We've also delved into the transformative effect it's having in healthcare, improving diagnostics and patient care, and saving lives. And let's not forget the challenges ahead and the future directions of deep learning. Despite some hurdles, there's no denying that deep learning represents a paradigm shift in AI, unlocking new capabilities and transforming industries in unimaginable ways. As we continue to explore this exciting field, who knows what incredible innovations we'll see next. If you like this video, please give it a thumbs up. We value your feedback, so feel free to leave a comment. Also, if you would like to see more content like this, please share and subscribe. Until next we meet, be well!